This is Unit 12, Lesson 9, and in this lesson we're going to be learning about the three reciprocal functions. So these three, remember, are the reciprocals of sine and cosine and tangent. So I'm just going to add that in here. So this one is the reciprocal of sine, this one is the reciprocal of cosine, and this one is the reciprocal of tangent. That will help us get some actual points because we're going to be going back and forth again between the unit circle and this graph. So first thing, when we have 1 over, there's a chance to have a 0 in the denominator. And we do have 0 in the denominator because sine can be equal to 0, so can cosine, so can tangent. So let's start there. With the tangent, a good place to begin was those vertical asymptotes. So with all of these ones, that's a good place to begin as well. So let's look at the reciprocal of sine. So whenever sine is 0, we're going to have a vertical asymptote. So that would be at 0, happens again at pi, and then 2 pi. Okay, so we have a vertical asymptote at 0 and pi and 2 pi. So we can mirror them back in the other direction as well. Okay, so that's the start. Then we can figure out, kind of look at some of the other common ones. Like this is a good one to look at. Sine is 1. Reciprocal of 1 is also 1. So at pi over 2, our value is 1. Which you have right here. And then at 3 pi over 2, our value is -1, because that would be the reciprocal of -1 as well. So reciprocal of -1 would be right here. All right, so those are a couple of easy ones to work with. Another thing that we can look at is like these, the 3 pi over 4. So 3 pi over 4 and pi over 4, these have the same value here. So if you take the reciprocal of those, we've got 2 over root 2, which is the same as 1 over root 2. So when I take 1 and I divide it by root 2, I'm going to end up getting, I'm sorry, I just get the square root of 2. So the square root of 2 is about 1.4. So here we have about 1.4, 1.4. The point is that we end up with these little scoops. So they kind of like glide along the vertical asymptote here through this point and then back up the other side. And these just repeat themselves over and over. So we have one in this direction and then they mirror. So this one would also be a -1 because it's in the same position as 3 pi over 2. So you have this little scoop. And then -3 pi over 2 is the same spot as pi over 2. So you can see that that is what the pattern is. So some info that we're going to put over on the right-hand side here. There is no amplitude because just like the tangent graph, it goes up forever, it goes down forever. So the amplitude is undefined. And then the period, you want to see how long it takes before it starts repeating itself. So we've got a scoop towards the top, a scoop towards the bottom, and then it repeats. So this whole thing would be a cycle length. So from 0 to 2 pi, that would be the period. All right, so we're going to be looking at something very, very similar for the secant. This is the reciprocal of cosine. So let's first look to see where those horizontal or where the vertical asymptotes are going to be. So cosine is the x-coordinate. So this is a coordinate of 0. So we would have a vertical asymptote at pi over 2. This is also an x-coordinate of 0. So we would have one again at 3 pi over 2. So pi over 2 and 3 pi over 2. And if we mirror these back the other way, pi over 2 back negative pi over 2, because that's the same as 3 pi over 2. And -3 pi over 2 is the same as pi over 2. So we've got that same spacing of asymptotes that we had in cosecant. They're just shifted. And then we can also figure right here, if the cosine is 1, that means the reciprocal is also 1. So at 0, the value would be 1. And then over here, the cosine is -1, so the reciprocal would be -1, and that's pi. So at pi, we would have -1. So same exact pattern that we have right here. It's just shifted a little bit over. So like that. So this one starts and ends here rather than here. So now this would be, this one would extend over here. This one would be the bottom half. And then right here, we'd have part of the top half of one. All right, so just like the one up above it, our amplitude is undefined. Anytime you have asymptotes, you go up forever, you go down forever, the amplitude is going to be undefined. And so here's how long it takes to go through one complete cycle. So same as the one up above, just shifted a little bit, so the period is 2 pi. Also, the period for sine and cosine would be 2 pi, so the reciprocal function would have the exact same period. All right, last one to look at is cotangent. This is the reciprocal of tangent. So we have some values that we were working on before. We talked about, and this is in the previous lesson, lesson 8, part 2, we talked about how at 0 and at 180, the value was 0. So we have like 0 over 1 would be the tangent. So if you flip that, that means that the cotangent is x over y. Okay, so like that's something that we can work with if we want to write this down. The cotangent is x over y. So same division, just flipped. So here, x over y is now undefined. So this one has an asymptote at 0. Here, x over y is undefined, so it also has an asymptote at pi. So asymptote here, which means it would also have an asymptote at 2 pi, and then we can repeat back. So every multiple of pi, this cotangent graph is going to have an asymptote, just like that. And then if we again flip and do x over y, it would be 0 at pi over 2. It would be 0 again at 3 pi over 2. So 0 right here, 0 right here, so you can continue the pattern. That means directly in between the asymptotes, you're going to have an intercept, so very similar to the tangent graph. And then we can look at a couple of other points. So like this one's a good one to look at. Remember the halfway point? So pi over 4, x divided by y would be 1. So that's right here. And then 3 pi over 4, x divided by y would be a negative 1. So x divided by y would be a negative 1 at 3 pi over 4. So that's this one. So really, really similar shape to the tangent graph, except it is reversed like this. Okay, so you can repeat that same pattern. These 3 points go in a downward diagonal instead of an upward diagonal. Okay, and one more of these. Again, downward diagonal instead of that upward diagonal. Okay, once again, the amplitude is undefined. And this time, if you remember from our last lesson, the period of the tangent graph was pi. So that means if all you're doing is flipping it, the period is still pi. So sine and cosine have a period of 2 pi, which means their reciprocals have a period of 2 pi. In the last lesson, we learned that the tangent graph had a period of pi, so its reciprocal also has a period of pi. So that's kind of the general info. We can also do the same exact transformation. So cosecant and secant, we apply the transformations the same for A and B. And then for cotangent, we apply the transformations the same for A and B. So we are working with that same general idea. Remember what A is a vertical stretch, so it kind of pulls them all this way. B changes what the period is, so that means it can make it wider or narrower in a horizontal direction. All right, so we're going to look at a handful of examples that involve some transformations. So we're going to look first at number 1. This is a cosecant graph, which means it's going to take on this general shape. Let's see what changes it's going to make. So 3, that's going to be like a vertical stretch. So what that means is anytime you have a value of 1 or negative 1, this is now going to have a value of 3 or negative 3. Asymptotes are still going to be the same because there was no value here, which means the period was 2 pi still. So this one had asymptotes at all of the multiples of pi. So 0, pi, 2 pi, etc. So we can still put those exact same asymptotes in here. Okay, so now these points, anytime you'd have a point of 1, you now have a point of 3. Anytime you had a negative 1, you now have a negative 3. So the first one goes up to 3. This one goes down to negative 3. This one is up at 3. This one is down at negative 3. So it's the same general idea. They're just pulled a little farther away from the x-axis than the original graph would be. Okay, so that's our first transformed graph. That's a cosecant graph. We're also going to look at number 2. Number 2 is taking a secant graph and transforming it. So it's going to take on the same general shape as this one. Here we do not have a stretch the way that number 1 does, but this is going to change the period. So we take the original period of the secant graph and divide it by whatever this number is. So remember, dividing by 1/2 is the same as multiplying by 2. So the period ends up being 4 pi. Okay, so the way that that works is we are going to stretch this all out this way. So multiplying by 2 means that they double in length, like how far apart these are. So if you normally have one at pi over 2 and negative pi over 2, you're going to stretch them out, and they're not going to happen until pi and negative pi. So pi and negative pi, like that. And then the next one would not happen. So like, see how far apart these are. This goes from negative pi to positive pi. The next one wouldn't happen until 3 pi. Okay, so 3 pi would be like somewhere over here. Negative 3 pi would be like somewhere over here. All right, so now let's do the rest of it. This point still exists. It's not any higher or any lower. It's still at 1 because there was not a value out front right here. So this value still exists. So this is like this big, wide secant graph. So same general idea as this. Now the next ones go down. So like to the right and left, these ones go down. So this would be right here, and it would go down. And then this one would be, if this is at 2 pi, this would be at negative 2 pi. So it goes like this. So stretching it out. Okay, so you see only half of a period in the same length that you normally would. So that's what that 1/2 does. All right, let's look on our next page. Our next page, the first example that we're going to look at is number 5. Okay, so number 5, we have half times a cotangent graph. Okay, so no change in the period, so the period is still pi. That means that our asymptotes are going to happen in the exact same place as the original cotangent graph. So here that is at 0, pi, 2 pi, etc. So always start with those asymptotes. That's going to be the easiest place to begin. So you know how far apart everything is, and then you can work with whether you have a stretch or a compression. All right, so now these points with a cotangent graph, directly in between the asymptotes, you have an intercept. So let's put those in there. So intercept here, here, a couple more on the other sides like that. And now the very last thing we want to look at is these go 1 up, 1 down, 1 up, 1 down, and that pattern repeats. Now this one has a 1/2 out front, so it's only going to go half a unit up and half a unit down. That's what that 1/2 will do to this graph. So repeat that pattern for the other 3 pieces. So that is going to be what we call a vertical compression. It's going to kind of squash it in the middle a little bit more. So it's going to make this little twist seem even more dramatic than the original cosine curve. Okay, so see this one is a little bit more stretched out. This one, the twist happens very quickly because of the 1/2. Okay, so go along the asymptote and the twist happens very quickly. And then we repeat that pattern as many times as we need to until we fill up the grid that we're given. Oops, missed that last point, but we get the idea. Okay, so we're going to look at a couple more. The next one we're going to look at is number 7. You'll see that it's a secant graph. You will also notice that we are affecting both of these things right here. Okay, so first the period. You take the original period of the secant graph and you divide it by this number right here. So our period ends up being pi. So let me show you how that's going to affect the asymptotes. So let's look at the secant graph. Okay, so our period was 2 pi before. That means everything gets cut in half. That means things are going to happen twice as frequently as they normally do. So instead of these asymptotes happening right here, they're going to push over to pi over 4. So instead of pi over 2 and negative pi over 2, it'll be pi over 4 and negative pi over 4. Okay, now look back at the original again. Originally, the asymptotes were 4 units apart like this, each set. These are now happening twice as quickly, so the asymptotes are going to happen every 2 blocks instead of every 4 blocks. Okay, so many more of these, okay, because that 2, what that 2 means right here is basically that things happen twice as quickly as they do in the original graph. Just to compare that with number 2, this number right here means things are happening half as quickly as they do in the other graph, which is what made this stretch out so much. All right, so these asymptotes are happening twice as quickly. Now remember what this means is that we're going to have a vertical stretch of 2. So these, right on the origin, right on the y-axis, we're still going to have our upward facing one, and then they just kind of repeat back and forth. This value is 1, and these values are -1. This 2 means that I'm going to go up to 2, and then the downward facing ones will go down to -1. Okay, so they just go every other, up, down, up, back the other way, down, up, down, up. And so we have these little alternating scoops. They're going to be pretty narrow because of the new adjusted period, and they're going to be farther away from the axis because of this 2 that we have right here. Okay, so this is what those secant and cosecant graphs look like. It's like these alternating scoops, one up, one down, one up, one down, and that cycle just repeats over and over again. This time it repeats many times because we cut our period in half. All right, one final graph, the one right next to it, number 8. So this is a cosecant graph, which means it's going to have that same general shape using the y-axis as our first asymptote, and then our scoops go up and down. That's the only difference between these two. This one uses the y-axis as our first high point right here. This one uses the y-axis as our first asymptote, but then the pattern still goes up, down, up, down. So this, 2 things we're looking at. This 1/2 right here, this tells us that our cycles are going to move half as fast. So they're going to be more stretched out like this one was, rather than condensed like this one was. So 2 pi divided by 1/2, dividing by 1/2 is the same as multiplying by 2. So they're going to happen twice as quickly. So as always, we start with the asymptotes. Cosecant always starts with its first asymptote on the y-axis. Now, they are currently 4 units away from each other. So now we're going to stretch them out this way. They're going to happen 8 units away from each other. So instead of being at pi, the next one's not going to happen until 2 pi. And this one, instead of being at negative pi, the next one's not going to happen until negative 2 pi. All right, now, this point, the point up at 1 happens right halfway in between these 2 points. So halfway in between has this little turnaround point. Halfway in between here has its little turnaround point. The last little detail we need to focus on is that that little turnaround point is going to be up at 3 or down at -3 instead. So the first one is the one that faces up. So we're going to have one that faces up kind of right here, but its turnaround point halfway through is going to be up at 3. So that is going to look like this. And then this one has to face down. So halfway in between right here, its turnaround point is going to be down at -3.